So in this video, we're going to prove the following expressions that we have here, where we have log xy to the base a is simply equal to log x to the base a plus log y to the base a here. So let's start with the first one here. So I'll do it from here. So it's a proof here. So now here we're going to prove that log xy is simply equal to log here the base a of x plus log y to the base a, like this here. So the first thing that we're going to do here is we make an assumption here. So meaning that we say let's use z here. So let z be equal to log the base a of x, and we also let w here be equal to log the base a of y, like this here. So now here we're going to use the definition of logs here. So using the definition of logs, so using the definition of logs, where we know that if you have a function y equal to a to the power x, then writing this from its exponential form to its logarithmic form here is simply going to be x equal to log y to the base a, like this here. So we're going to apply this here to the two expressions that we have, which is this expression and that expression there. So we'll change this from its logarithmic form here back to exponential form. So when you look at this here, we're simply going to have a to the power z is equal to x, like this. We name this one as our first expression here. Then we convert this as well into its exponential form. We're going to have a to the power w here is equal to y, like this. So now we check here. These two functions that we have inside are being multiplied. So meaning that you are simply just going to say multiplying 1 into or multiplying 1 by 2 here. So multiplying 1 by 2. So if we multiply 1 by 2 here, so let me just do this. Okay, so now if you multiply 1 by 2 here, we're going to have a to the power z multiplied by a to the power w here being equal to x multiplied by y, like this. So according to the laws of indices, if the bases are the same, we add the powers, meaning that here we're going to have a to the power z plus w here equal to xy, like this. Now here, applying again the definition of logs, if we change this from its exponential form into log form here, we're simply going to have z plus w here is equal to log xy, like this, to the base a here. Now, since we made an assumption when starting to say that z is equal to log to the base a of x here, and w is equals to log y to the base a here, we make these substitutions into this expression that we have here, meaning that where there's z, we put log x to the base a, and where there's y, we put or where there's w here, we put log y to the base a here. So meaning that here we're simply going to have log the base a of x plus log y the base a equal to log xy the base a, like this here. So when you look at this here, it is exactly what we need there. So therefore this is how we prove that one there. Okay, let's also prove the second one. Okay, so for b here, we need to show that log a okay, let me just erase that. Okay, so x divided by y is simply equal to log x here minus log y to the base a, like this. We do the same thing that we did in the previous example there. We make an assumption. So here we say let w here. Okay, so I'm just going to switch a few things. So let w here be equal to log x like this here, and z be equal to log y like this here. So now, using the same definition of logs, so using the definition for logs, so using the definition of logs, where if you have y equal to a to the power x, this here, so this is in exponent form, so if we take it to logarithmic form here, we're simply going to have x is equal to log y to the base a like this here. So we use this relationship that we have here on the two assumptions that we've made here, meaning that here we say a to the power w here is equal to x, so we can call this one 1 here, then a to the power z is equal to y like this here. So if you check here, these functions that are inside the log there are being divided, or they're dividing by each other there. So meaning that even here we're going to say dividing equation 1 by equation 2 here. So here we say dividing equation 1 by 2. So if you divide equation 1 by 2, we're simply saying you're going to have a to the power w here divided by a to the power z is simply equal to x divided by y like this. Okay, let me finish the proof from this side. So now here, if the base is the same and you're dividing if you're dividing expressions that have the same base but the powers are different, we just subtract the powers here. So meaning that here we're going to have a to the power w minus z is equal to x over y like this. So here we we apply this same principle that we have here. So if you check this expression that we have here, this is in exponent form, it's in exponential form. So meaning that we need to write this now in logarithmic form here, meaning that here we're going to have w minus z here is simply equal to log x over y to the base a like this here. Now remember, in starting our proof we say that w is equals to log x to the base a and z is equal to log y to the base a here. So meaning that we substitute into this expression that we have here. So meaning that here we're simply going to have log here x minus log y to the base a equal to log x over y like this. So once we do this, we've proved to say that the two expressions there hold them. Okay, thank you.